Audio Jungle. Audio Jungle.
So the problem is uh, find center of gravity of a channel. Okay, channel section, that is this section, and dimension they have given. What dimension they have given? 100 mm by 50 mm by 15 mm. This is the dimension they have given to us, right? Now based on this, we can have the channel, we can draw like this. Okay, see, we can draw the channel, nothing but first 100 mm, okay. Now see, so and here this is nothing but here or here anywhere 15 mm, and here this is nothing but 50 mm, and this is nothing but 100. For this channel we need to calculate center of gravity, right? Center of gravity for this particular channel. Now if see this channels, C section, one more time I have to draw, then it will be more clear. If you see this channel, how many section we have here? 3 section, right? We have a 3 section, and this dimension is nothing but 15 mm, and this is nothing but obviously 50 mm, and here it is nothing but 100 mm, right? And if you see, this section is what basically parallel to x-axis, because if you draw axis here, so you can say this is x-axis and this is y-axis. So no doubt this section or this channel is what? It is symmetrical about x-axis. Yes or not? So symmetric symmetrical about x-axis. Okay. So it is very clear. Now your CG will lie about x-axis. Okay. So if it is symmetrical about x-axis, that means it's very clear that it is clear the CG Okay, center of gravity will lie, CG will lie on x axis. Okay, now what to do if it is on x axis? If it is lying, then obviously we have to calculate, because two types of cases is what possible: bisymmetric and unisymmetric. Unisymmetric means it is symmetric about x axis, or it is symmetric about y axis, or it is symmetric about both axes. If it is symmetric about both axes, called bisymmetrical section. So it is only symmetric about x axis. So if it is symmetric about x axis, now it is very clear the CG will lie on x axis, because on which axis it is symmetric, on the same axis CG will lie. That's the mean of it, right? So here we have to calculate x bar now. All right, if you calculate x bar, then to calculate x bar, how many section we will have? A 3 section, you can say. What are that 3 section? I'll show you. These 3 sections are basically right. This is the one section. See, this is the section 1, and here this is the section 2. See, this is the section 2 up to here. Where is the third section? Your third section is nothing but this one. Third section. For all 3 sections, we can say this is what 1, this is what 2, and this is what 3. For all 3 sections, we have to calculate. We can make a separate calculation, and then we can find so x bar, because if I want to calculate x bar, because CG is what, now it is very clear, CG is what lying on x axis. So we are going to calculate x bar. What is the x bar? X bar is nothing but summation of ax divided by a. That means it's a a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Okay, now what is the a1? A1 is the area of section 1. So we can calculate a1 is the area of section 1. What is the value? Check section 1. Where it is the section 1? It's nothing but 50 into 15, right? 50 into 15. 50 into 15, which is nothing but 750 mm square. What is the x1? X1 is nothing but the CG location. We can take individual value, and if you check how to get the CG, already I have told you for this particular section, you meet the diagonal. So diagonal will meet something like this. So the total distance is nothing but, see, the total distance is nothing but uh, in terms of x I'm finding, right? So the total distance is nothing but 50. So this distance I have to write, sorry, this distance I have to write. The total will be 50 here. Where it is lying, it is exactly 50 by 2, means that is 20. This is the x1, right? Now coming to the value here, x1, that is 50 by 2, that means 25 mm. Similarly, we can calculate a2. What is the a2? That is area of section 2. It is nothing but 100 into width is 15. It is all for all sections, so 100. Okay, check this area I am calculating. So here, obviously, this is what 15. This part you can remove from this. This is what 15 and here also 15 you have to remove. Now, so this length will be what? 100 minus 15 plus 15, that is 30. It's just 70 only. Hope you understood. It's nothing but 100. Uh, Better I will write 100 minus 30 into 15. That means uh, the 10 square. What is the x2? If you check x2 is nothing but, again, okay, I'm taking the reference for the y axis obviously, because CZ will be lying on x axis. So if you check, you are calculating the for second section. So second section is something like this. See, something like this. Okay. What is the width here? It's nothing but 15 So where is the CZ? CZ is not somewhere here, na? So CZ will be x2, that is 15 by 2, just half of this. It is nothing but 7.5 Coming to the third section, A3. Obviously, first and third must be same. So what is the third section? It's nothing but take 50 into 15, right? 50 into 15. And what is the x3? X3 is nothing but just half of the 50, which is nothing but 25. Nothing but 25. Right. Now, what is the x bar then? That is the CZ. If you check CZ location, x bar is nothing but A1 x1 plus
Sir, you're on mute if you're saying something.
If you draw this section something like this, and for this C section, if you check, this is X axis and this is Y axis, then where is the CG location? It's nothing but CG location is what, somewhere here. What is that distance? 17.8. What is the X2? X2 is 7.5, and width is nothing but 15, right? Width is nothing but 15, so 17.8 will exist somewhere here. This is the 2G location, because if you check this value, okay, if you check this value, so it's nothing but that X direction, because CG will lie on X axis because it's a parallel to X axis. So your CG will exist somewhere here. Okay, so if this is your reference now, this is your reference. Suppose this is your reference. So for from the reference, if you measure, then this distance is nothing but 17.8 mm. Okay, because this is 15 mm, right? And obviously this is what, 50 mm. So 17.8 somewhere will exist on X axis, but from the reference 17.8 we will have. I hope this one is clear.